Hi, everyone. Welcome to Topic Modeling in Python, how a data scientist finds what not to wear. I'm excited to have you join us. So before we get started on the technical portion, I wanted to give everyone a high-level overview of a data scientist for those of you who may be hearing about this for the first time and how you can use one on your team. I then wanted to go through an analysis highlighting some of what a data scientist does on a given day. So what is a data scientist? There are many definitions as there are people, but here are some of my few favorite quotes. By definition, all scientists are data scientists. In my opinion, they're half hacker, half analyst. They use data to build products and find insights. A data scientist is someone who can obtain, scrub, explore, model, and interpret data, blending hacking, statistics, and machine learning. Data scientists not only are adept at working with data, but appreciate data itself as a first-class product. I really like these first two quotes because it covers the breadth of the technical areas of data science. It's not any one of these things, but rather a blend of all of them that makes a good data scientist. Now, these next two quotes, I really like these because these are focused more on the storytelling part of data science. So the goal is to turn data into information and information into insight, says Carly, the former CEO of HP. And data scientists are involved with gathering data, massaging it into a tractable form, making it tell a story, and presenting the story to others. I think this visual really sums it up. Now, a data scientist is someone who can do all of these things. They may not be strong in all of these areas, but they should feel comfortable diving into any of them as needed. So how can you use one of these on your team? From Google to Facebook, collecting and tracking every search and every click, to the company manufacturing physical products, collecting data every second, such as your Fitbit, to a simple business owner with a website. You have data and you can leverage your data to improve the bottom line and give your customers what they want. We do not have a lack of data problem, we have a lack of information problem. Now you may have noticed the code at the top. I'm actually presenting these slides using Jupyter notebooks, which is the tool where the code, the text, images, anything can be kept in the same notebook. This notebook can be converted into presentation format. I love using notebooks to keep track of my work on a daily basis and show my results. Also, I want to note that some of the code and results can be skipped in presentation mode, but will be there in the original notebook. So you'll be getting a copy of this notebook after the webinar, so you'll have access to all the code even if I skip over it here today. So the first thing I wanted to cover is data munging. So the most important thing for a data scientist is to have good data. Without good, trustworthy, reliable data, we can't derive good information and therefore insights. Remember this motto, garbage in equals garbage out. Most of what a data scientist will do, unfortunately, is this data cleaning, verifying, and obtaining. I've heard it's an 80-20 rule. 80% is spent on cleaning data and feature extraction, and 20% is on the actual modeling. This number was made popular by a New York Times article a few years ago, and I have the quotes up there. So let's get into our data set. So I'm going to cheat a little here and download a relatively clean data set from a data set repository. This is a data set that had a list of URLs of dresses and some text describing each dress. This was my starting point. Now, when I went through and did the analysis the first time using the data just from this data set, I didn't really get good results, and it's because the data set didn't have many words describing the dresses. An analogy to understand this is to think about having the world's population, about 7 billion or so data points, and just knowing the gender and age of each person. We could answer a few simple questions with this data, but not much. These are called features. The better features we have, the more interesting questions we can ask and better insights we can gain. So once I saw that this text wasn't enough, I went and scraped the data off the website itself and grabbed the keywords and color information if they had it. So here is the code I have for actually scrubbing the website. I won't go into the details of this code. It will be available after the webinar. But really, what I did here is I basically opened up each URL and looked for an image. If the image was in the page, then I just took a copy and saved it. Now, it's very important to save your data if you're using data off the internet, because the internet is constantly changing. I learned my lesson the first time because I didn't save my images and I lost a bunch of them and I couldn't use them for this presentation. So just lesson learned right there. Make sure to save data if you're pulling it off the internet. Okay, so now we're going to get into the data janitorial work. And this means we need to go and clean up our data. So right away, just looking at this data here, so this is the data that came out of that repository. We have some things are lowercase, some things are uppercase. Let's go dive a little bit more and see what's in our data. So here, right away, we have dress attributes, and you notice that they meant to have waistline, and they have waistline. So these are the types of things that someone will have to go through and actually fix. So we're just going to go through and start cleaning up some spelling. And here I'm just looking at all the words that we have just to see, do I need to do any more cleanup? And it looks like we do. We have a bunch of misspellings, some capital letters, lowercase. We're missing some values. So let's just start cleaning up this data. And right now, I'm just going to spend a couple of slides just showing some examples of what cleaning up data looks like. So here we have anything that didn't have any value, we're just going to put the word null in there. And anytime we see a dash, we're going to replace it with a blank. There was a misspelling of the word autumn, so we're going to fix that spelling. Leopard was spelled wrong, so we're going to fix that. Here there was a bunch of misspellings and variations of sleeveless, and so we'll just fix all of those misspellings and move on. So here I wanted to talk about, feature selection. So one thing I wanted to mention is that we want to focus on similar dresses based on their material and how they look, and not worry about the price or rating or anything. Feature selection is a very important part of the process. If we're trying to showcase similar clothing on a website, then maybe I would use cost because people tend to shop and want to stay in a price range. This is more of an art than a science. It's really based on the problem at hand. I would like to find dresses that look similar to the dress I like, and I'm not really worried about rating or price at the moment, so I'm not including those. So let's look at an example of the text and a dress. So here's an example of the data that I'm capturing. I've pulled out all the keywords from the website, which is right here, and I'm just showing the visual that I pulled out that I scraped from the website. Okay, so now let's start with the text mining. So our goal is to convert the words that we've captured into numbers so we can do some machine learning on it. First, we need to create a dictionary from all the documents in our corpus. The corpus is what we call the collection of the documents that we have. There are many ways to determine what words belong to this dictionary, and I'm going to briefly cover two popular methods: bag of words and TF-IDF. Bag of words is very straightforward. So here's a great visual of bag of words. And so imagine that you have all of the words in our documents in a bag. The unique words make up the dictionary, and we can create a vector by assigning each word to a location on the vector and having a 0 or 1 based on whether that word appears in the document. So here we have an example of nice day and a very nice day. So all of our words is in this vector, and for the first sentence, nice day, we would have a 1 for nice and a 1 for day, because only those two words appear in that sentence. And so imagine that each of your documents represented one vector. So now, with all of our documents and all of our words, we have a big document word matrix. Now, another approach is called TF-IDF, which stands for Term Frequency Inverse Document Frequency. Here we also have the words assigned to a location on the vector, but instead of a 0 or 1, we'll have a weight. Here I have the definition from Wikipedia. I like this definition because it was just very to the point. It is a statistic that represents how important a word is in a document, and it's used as a weighting factor. And so let me just show a quick visual to describe this. So if you imagine, stop words here are words like the, and, I. It's something that we see in every document. And rare words would be a word like Chewbacca, unless you're watching South Park, of course. Frequent words are the words we're going to see a lot of due to the content and the topics in the document. So our goal is really to pull out the frequent and rare words. So here, I'm using a function in scikit-learn, which is one of the packages in Python for doing machine learning, and it's called TF-IDF vectorizer. And what it does is it takes the documents and converts them into vectors of numbers like we described earlier. This one slide just shows a few lines of code, but most of the work went in here. This was iteratively modified as I would check my results and realize that I needed to pull out certain words that were just noise in my data set. Those are called stop words. So as I was running through this analysis, I would look at my results and my clusters, and I realized, okay, there's words that are related to size, and that's not really helping. Just because one dress is available in medium and large, and so is another dress, that doesn't make it similar, or not the way I was defining it at least. So then I would have to go back and pull out those words as stop words. So this is a very subjective part. You're doing text mining. I deemed certain words to not be relevant. Someone else with a different data problem might decide to use those words. For example, if you're actually shopping online for a dress, you would want to know, okay, this dress is available in medium, this is important to me, I don't want to see dresses that are not available in that size. So just make sure to keep in mind the problem you're trying to solve when you're cleaning up your data. So now that we've run this, let's look at some of the terms that show up in our dictionary. And we see, so I'm just going to slide through a couple of these, but we see, blouse, boat neck, bridle, so just the words that were seen as important. Part of the TF-IDF functionality also has ways to filter out noise. So I said, okay, if something doesn't show up in at least 2 articles or 2 documents, just remove that. So some things like misspellings can be easily removed that way. Okay. So next, so it's always a good idea just to look at the data to make sure it looks as expected, nothing looks weird. So here, it looks great. This is the text that we're pulling out of the website. So let's move on to the topic modeling. So here we are going to use a common approach to find topics by using non-negative matrix factorization. So don't worry about that long term. Just think of this as factorization with numbers. You're trying to find 2 numbers that multiply to give another number. That's what a factor means. If you've taken linear algebra, you might remember that if you have a matrix, you can break it down into pieces, into factors. So here, where we have this term document matrix, and if you remember, that's each row and column, they represent the documents and the terms. And if we had used a bag of words approach, there would be a lot of zeros in there because not every document contains every word that's in the dictionary. And so this type of factorization helps us break it into a term topic matrix, which means that for every topic, we have a bunch of terms that belong to it. And then we also have a topic document matrix, which means now, instead of describing the document in terms of the words that were in it, we're going to describe the document in terms of the topics it belongs to. And luckily for us, scikit-learn also has this available. So now we're taking all of the documents, which are the descriptions, and we're going to summarize it into 10 topics. And the number of topics you want to describe it in is really arbitrary. I try to look at, when I'm doing this on a larger scale, to make sure that every topic is, that we see an equal number from each topic, and we don't see, one from one topic and 1,000 from another topic. That means maybe I should reduce the number of topics that I'm looking at. So now, using this, we can actually visualize the word clouds of the topics. So remember here, we put in a bunch of text that we pulled out of the web. We cleaned it up a little bit to pull out things that we weren't really interested in. And now, this is a very automated thing. Like, we're just saying, hey, sort of summarize all the data I have into 10 word clouds. Show me the 10 top topics of all these dresses. And you can think of it a way as, like, if you had any text, this is a very easy way to just summarize all your text. So here are the 10 topics, and I'll scroll through them. So we have, a bunch of fashion, black dresses, we have lace dresses, we have printed dresses, evening dresses, pencil skirts, chiffon, wedding dresses, casual, and so on. So this is a really great way to, without having to read through everything, you can get a high-level summary of what is in your data set. Okay, so let's get to the what to wear part. So here, I basically found a dress. I was like, okay, I'm looking for a work dress. I need something for work. I like pencil skirts. It would be great to find an outfit just like this. I like this one, but what are some other dresses that are similar to this one? And just remember that we're finding similar dresses based on the words, not the actual visual here. So if you notice, this is our words in the dictionary, and it doesn't include anything like red. So we shouldn't expect that the color will be similar, just the words. And so now we're getting the top 5 that are similar. So of course the dress itself is the most similar in our data set. And so here we have, okay, so it's a dress that's, it has a pencil skirt, it looks professional. Here's another dress, looks like appropriate for work. Here's another dress. And I just wanted to mention here, so I had mentioned pencil skirt, but here we don't actually see the word pencil anywhere in the description of this dress. Now, the thing about topic modeling is that topic modeling can actually infer words. So there could be words that are usually used when pencil dresses are described, and if those words are used here, it'll find them similar. And that's the really kind of interesting thing about topics, because it can learn synonyms. It doesn't necessarily have to be the same word. If multiple words are used together and a separate word is used, it will still find a similarity. And here's our last pencil skirt outfit. So now here, what not to wear. We can see right away, these look very different from the dresses that I was looking at before. I'm not sure that I would really wear any of these to work. We have a very flowery dress here. We have a party dress, another party dress, and another very, very bright. It is my color, but it's a little too bright. Okay, so now let's move on to the clustering portion. So what we had done before is that we had looked at one dress and we had used some sort of distance metric to find, okay, let's find all the similar dresses. So we were finding all the things that were closest in a certain space. Now what we're going to do is we are going to be taking all of the dresses we have and say, okay, let's just cluster them. Just find me like similar groupings of dresses. And this is just, I'm just showing the results again of the clustering. I'm not going into the details of the clustering algorithm I used. If you want to see the code, it will be in the notebook later. But you can set a cluster diameter, which says how close the items of the cluster should be. And this is a tuning parameter, and I just made the cluster sizes pretty small so that we could look at the results. So here's one of our clusters, and we can see that we have this long chiffon. They seem to all be sort of this chiffon fabric dresses. I think that was sort of the highlight here. And what I did at the bottom here is I just took all the words of the descriptions of the dresses just in this cluster, and I put a word cloud together. So here, these were all chiffon dresses, and they were natural, and they have O-necks. Again, this is just the words that appear for this cluster. And let's just look at a couple more. So here we have lace dresses. Yeah, this is very lacy. This is the lacy cluster. So these are like mini casual lace. And I wanted to highlight, once we get to the next one, so here we have wedding and wedding lace. Notice how lace is actually common to the previous cluster and this cluster, but this was able to separate out lacy wedding types of dresses versus just lacy casual dresses. So here, lace and wedding were dominant words in these descriptions. So these clusters are, they're looking pretty good, but remember that we were clustering them based on their words. So we could have gone further to use the pixels themselves to cluster by color, but this would have been an image processing problem and not a text processing one. So maybe we can do that for the next webinar. So why does this matter? So as we just saw, the work that a data scientist goes through when creating a machine learning problem is not black magic, but rather an equally creative and technical human-in-the-loop process. Extracting information from data requires feature engineering and noise removal. You can't pull out information that isn't there in the first place. Like we weren't able to pull out the color information in our dresses because we were only using other descriptive words. Data science requires a diverse set of skills. On any given day, a data scientist could be wrestling with a database, doing matrix decompositions, or trying to figure out what chiffon really means. It is important to have subject matter expertise in the business. Let machines do what machines are good at, and let humans do what humans are good at. The best combination of doing data science is to have the perfect balance between the processor and the brain. So current text mining applications include competitive intelligence, automated ad placement, customer relationship management, sentiment analysis, and more, which can be found in the links. And so I just wanted to exit out of this because this is the end of my slides, and I just wanted to just show you what my notebooks looks like, because I took a notebook that I was doing my work in and was able to just present it right away. So here's the complete set of my notebook with all the notes and extra code to be able to smoothly go through this. And you can take this and run this, and you'll be able to mimic and modify any of the code that you want. It would be great if you were able to take this and even apply it to another data set, another website, I got a chance to play around with overstock.com. I highly recommend it if you want to try this analysis on a different data set, but still looking at keywords. They had a great set of keywords for all of their clothing on there. I just wanted to move to the bottom here. So how can you use this? So I just put up a couple of links so that you can find other machine learning applications and how you can use text mining for your problem. But that is pretty much all I have. And I know that I brushed over a lot of the more technical details, but I did include links to be able to understand, non-negative matrix factorization and what TF-IDF really is and what bags of words are. I included all those links so you can read more about these things. It took me a long time to learn about those concepts, so it's not something that we would want to try to cover in an hour or half an hour time slot. So that's all for now, and I'm open for questions.
Great. Thank you, Jaya. This is awesome. And I think all of our attendees are really excited to get this notebook, especially if it's something that they can take to other data sets and apply. So thank you so much for making that available. So we've got time for some Q&A, and I actually have a couple of questions that have come through already. So while I get those ready, attendees, if you've got a question, please put it in the chat function, and we'll get them over to Jaya. And then any questions that we're not able to get to today, we will send you a personal follow-up email with those answers. And then everyone who's here, you'll get a copy of the recording as well as the notebook, which is fantastic. So Jaya, I do have a question that's come through from our listening audience, and it is, if you have a lot of data and don't know what to look for, how do you start?
So I have a client that I'm working with right now, and they have a lot of data, a lot more than I have seen before. And the problem I'm working on is a very specific problem, and so my natural data science tendency is to try to understand all the data that's out there, but sometimes it helps by just starting with what is the business problem here. And before you even look at the data, just think about that business problem and think about, okay, what data would I need to be able to answer this business problem? And then you can look at your data and decide if you have that data. Have you been collecting that data? And if you have been collecting it, focus there and start there and really test that hypothesis of, okay, does this feature, is it really important to the answer of that business question? And the other thing I would say is if you're not collecting the data that you think should be helpful, then it's time to contact IT and have them figure out a way to start collecting that data.
Awesome, thank you. Okay, well, I've got another one here, and then I see we've got another one coming in from the audience. So, guys, send those questions over. But the next one we have is, this is a bit of a long one. What's the time investment for something like this exercise? For an example, if I go out and get a data scientist or a team, how soon can I expect to get actionable results?
Okay, so putting this together, there's many levels to it. It's really true that most of the data work is in that early stage of cleaning and pre-processing. Let me just go up to the section that probably took the most time in doing this, and it's right here. These stop words and figuring out exactly how I want to vectorize my data. We weren't able to see this in the presentation, but right here, there is token pattern. I had to run through this and realize there is a lot of numbers in our data set, and so I want to remove the numbers. And I want to only look at things that were 3 letters and more. And I want to remove anything that's in more than 80% of the data. And then again, pulling out these words that would keep sort of messing up, my similarity or my clusters. So that is, where most of the work is. If you wanted to have a very high level, like, I don't want to put in any of this work,
in, really cleaning. If you have, let's say, 1 million documents, and you're just like high level, just show me what's in there. You could do this pretty quickly, probably a couple of days, just saying, hey, high level, summarize, give me a 5-topic summary of what I have in this data. Definitely in a couple of days. I mean, the longest thing would be to actually process that data. We might need to move onto a cluster as opposed to doing it on my laptop, but the work involved, I mean, these are off-the-shelf functions in scikit-learn, the Python package that I use all the time. And so really, I feel like I can do anything with the functions in there. So it is easy to do, but it's, really understanding like, okay, what is this that I'm doing here, and not just blindly like applying an algorithm, but so that's where more of the time comes in. But I would say definitely a couple days, a week. And then if you want to have very specialized, very, if I'm trying to predict the disease that someone has based on their description of their ailments, then I'm not going to just do some quick ad hoc thing and say, you have this horrible disease because you used all the words that other people use when they have that disease. So it really matters like how much accuracy you want to have.
Awesome. Okay, great. Thank you so much. Guys, if you've got any questions, go ahead and send them over. We've got one more that Jaya is going to take a look at right now that just came in from the audience. And, it looks like we've got 2 from this person. So if you want to do this one and then the next one, I'm happy to read it out, which is, how do you build the corpus when facing a large amount of websites, let's say 100 websites? How would you pool the text to corpus?
Okay. So this is a great question, and I was actually trying to figure out if I wanted to include it in my talk, but I just didn't want to cover like so many topics. So let's go to the section where I have Beautiful Soup. So here I'm using a package called Beautiful Soup, which is really great at parsing HTML, and parsing, images and just keywords out of HTML. There is another Python package called Scrapy, and Scrapy, C-S-C-R-A-P-Y, it has like a spider as its image. So Scrapy, what that does is you can actually give it a starting website, and it will scrape for you and find you all of those HTML pages that website is pointed to. So if you wanted to start, let's say, overstock.com, you could use Scrapy to just start up the main page and have it basically crawl around and get all the HTML files for you, or HTML locations. And then you could use Beautiful Soup here, which I did end up skipping over this in the presentation itself, but what Beautiful Soup is doing is I have a bunch of URLs, and it goes through one by one, and it pulls out what I need. So by using Scrapy and Beautiful Soup, you can both get all the locations, the websites that you would like to pull the data out of, and then using Beautiful Soup, you would loop through and actually pull that text. And of course, remember here, please put the text somewhere where you can then access it. So you might want to try a Postgres database on your machine if you're doing this locally. I've done that before, just so that I have it on hand, and because the internet, it will change, and so you might have a URL and data one day, and the next day it's gone. So make sure to store it once you've grabbed it.
Awesome. Thanks for that answer, Jaya. We've got another one that's come in for you. Guys, we've got a few more minutes left. It's only 12:36 Central, so if you've got a question or two, send it over. The next one, does stemming in the cleaning process help to always get a better result?
So this is a great question. So I actually didn't use stemming proper in my cleaning up here. I had played around with stemming, but I didn't like how the stemmer I was using, which is actually from a package called NLTK, which is another Python package for doing text processing. It had I think I tried the Porter stemmer and the WordNet stemmer. And it really became just, what is it that I'm trying to get out of the data? And I think it was the word embroidered and embroidery. One of the stemmers, it kept it as 2 words, and it just, one of them chopped off the Y, one of them chopped off the ES, and so I was like, okay, it's not exactly doing what I want, so I'll just I'll keep everything. So here I'm not doing that type of stemming, where you remove end S's at the end, or things like, or ED, and break it down to just the stem itself. But cleaning the data, if our dictionary had a ton of words that were very diverse, we may not need to go through the cleaning process. I've worked with data sets that are much larger and have much more diversity, and some of those words that are not as important really did just filter out more naturally. But I think here, because we didn't really have a lot of words that were in each of our quote-unquote documents, and so I did have to spend a little bit more time pulling out some of those stop words.
Great. Thank you, Jaya. They're coming in, so I've got another one. R or Python for text mining. What was the best topic modeling algorithm you've used so far? And then the follow-up is, how about LDA?
Okay. So I am biased. I love Python. I use Python all the time. LDA I have used, and in my experience with the specific document set that I had used before, I was getting similar results with LDA as compared to this, which is, I'm doing a latent semantic analysis here, which I have more details in the page. I just didn't want to go into it during this webinar. But what I found is that the results were similar, but the time it would take, it took more time to use LDA as opposed to LSA. And so I've just pretty much used this for the quick and dirty. But I do know that LDA is sort of like the one that everyone uses now, and it's the top algorithm. I have used it in Python. I think that's, yeah. But I don't have any recommendations, R versus Python. I like Python because scikit-learn as a package is amazing. Every single machine learning algorithm I've really wanted, I've seen there. They just started adding a couple of neural net algorithms, and so they're really trying to stay on top of sort of what people want. I mean, it's an open source package, so of course people want stuff, and then they go and put it in there. So it's really great. If you guys are familiar with Spark, Spark's machine learning library is trying to mimic scikit-learn as much as it can, and it's how the functions are called and everything. So it's a really easy package to use, and it's nice that everything's in that one package. And I know with R, some of these functionalities, you have to go find it, in this package or that package.
Awesome. Thank you, Jaya. So did the last question answer that one? The last answer?
No. So you have here, the question is, what IDE do you recommend for Python? So personal favorite, I'm biased, I love Jupyter. This is a Jupyter notebook right here, and this is a live notebook. I mean, I could have been writing code and running it while I was giving the webinar, because the presentations that you saw were it's the actual notebook, and so that is pretty cool. I am doing a lot more analysis when I'm doing my work, and so I really like notebooks. Once the analysis is done, and let's say I'm going to pull out a couple of functions to put into a utilities package or production, then of course I would use, I've used PyCharm, but really I think it really matters what you're trying to do. PyCharm is great for production or development, and I like Spider. Spider is really good for, it looks very much like MATLAB, so if you're used to MATLAB or RStudio, Spider, it looks very similar to that, and it is for Python. I install all my packages using Anaconda, and I'm pretty sure that the Anaconda installation has Spider and Jupyter notebooks as a part of it.
Great. So I have another one that's come in. Is there any obvious method or way to measure the potential overcleaning of your data?
To measure the potential overcleaning of your data. You know, I am not sure.
We can always take this one as maybe something to follow up.
Yeah, that would be great. Yeah, that would be great because yeah, as I was going through this, I mean, again, like some of the things that you saw here, it's also due to the size of our data set. Sometimes when data sets do get very large, the cleaning is easier because it's just the noise that you can remove more easily. And here also, because I'm showing pictures that were related to words, I wanted to make sure that you know, the pictures looked similar, even though we were doing a word analysis. But then that was mostly for presentation. Great. But no, that's a really good question.
So I'll add this one to the docket for the follow-up. That is the last one that I've got in our queue, and we're right at 12:43, so we could probably give some folks some time back. Like I said, everyone will receive Jaya's notebook, and you'll also receive a recording of this presentation, and we'll include a follow-up for this last question. If you've got any additional questions for Jaya, send us an email. Be sure and follow her on Twitter at datanerd_Jaya. She always pushes out a lot of great content. And if you think of anything else, just send it over. But thank you all so much for the time today. It's been a pleasure. Jaya, thank you so much for sharing your expertise with us all. It was really interesting and a great visual experience. So with that, I'll call it a wrap.